All right, guys, so what we're starting today is writing the equations of a line in standard form. And part of that is slope. The slope of a line, m, of a non-vertical line passing through 2 points, is in the ratio of rise to run, rise over run. So slope m is equal to rise over run, or the change in y over the change in x. Or we sometimes write it as y2 minus y1 over x2 minus x1. The change in y over the change in x. Now, sometimes they'll write it, and this is getting up even higher in mathematics, as kind of triangle y over triangle x, and they call that delta. They call that triangle delta, so delta y over delta x, the change in y over the change in x. It's just the same way to write it. Now, if the line rises to the left, from left to right, so it's going up as we go from right to left, it's considered to have a positive slope. And going from left to right, if it's going down, it's considered negative. So if it's going this direction, it is positive. And if they're coming down this way, it's going to be negative. And we always read these charts from left to right. So if it's from going left to right, if it's going up, it's positive. And from going from the left to the right, it's going down, it would be negative. And that's really what we're going to be looking at first, is looking at these here, looking at rise over run, the change in y over the change in x. Now for these first two here, we want to describe the slope of each line and then find it. So looking at letter A, looking at this problem here, as we go from left to right, is the line going up or down as we go from left to right? So we start at this point here and it's going up. So it's going up as we go from left to right. So the slope would be positive, because if the slope is increasing from left to right, it's going up, it's increasing in value as we go along the chart, it would be positive. It would be a positive value. But now we want to find what the actual slope is. We want to find out m, the value of m. Now we're going to do rise over run. Now there's two ways we can look at it, and we're going to look at both. I'm going to look at probably what y'all would consider the more complicated way first, and then we'll look at a kind of easier way to look at this. Now, our general equation is y2 minus y1 over x2 minus x1. So when I look at this here, well, I have a point 3, 2, and negative 3, negative 2. So we'll take the y value. So the y value is always second, because any point on a graph is given in the form x comma y. So here, one of my y values is negative 2, minus the other y value is 2. Now the x values, so the x values are always first. Well, one of them is negative 3, minus the other one is 3. Now at this point here, you can type all this into a calculator. You can type in a calculator 2 minus 2 over negative 3 minus 3. Well, 2 minus 2 is negative 4. Negative 3 minus 3 would be negative 6. Any questions on any of this here so far? Any questions on anything we've done so far? Well, looking at this here, two things kind of pop up. One, and we have a negative over a negative. A negative and a negative make a positive, yes? So our new one's going to be positive. Is there a common factor between 4 and 6? Can we reduce 4, 6? Because they both have a common factor of 2, yes? So this would reduce to 2/3. So the slope is 2/3. So we have a positive slope, because again, it's a positive number. If the slope is a positive number, we're going to have a positive slope. And it would be 2/3. Any questions on this here? Any questions over anything we've done so far? Now, I did say that there's an easier way to do this, yes, than doing these equations. So now the easier way to look at this and do this slope, now we said the slope is what? The change in y over the change in x. The change in our vertical over the change in the horizontal. So looking at this here, how far did this go up? It went up 4, yes? So we have a rise of 4 and a run of 6. So if I can look at a graph and I go from this whole point over and up to this whole point, well, I would go over 6 and up 4. The change in y would be 4 and the change in x would be 6, which would reduce to 2/3. It would be the same thing, yes? So we can do this with a graph looking at the rise over the run if we're given the graph and kind of we have these nice whole points. But if we don't have them, we can still use our equation y2 minus y1 over x2 minus x1 like we did at the beginning. Any questions on the first example problem? Any questions on this here? Let's look at the next one. So as we look at this line, how is the line going as we go from left to right? It's going down, isn't it? So the slope for this here would be, if I can spell slope, slope would be negative. The slope would be negative because the line is going down. Yes? It's decreasing. Now looking at the graph, do we have nice whole points that we can look at going over and down? Well, yes, it actually also told us, didn't it? It told us the change in x and the change in y. So looking at this here, how much did the y change on this chart here? How much of a change did we have going up and down? It went down 3, yes? Because from this point here, try again. So this point here to this point here, well, the y values went down 3 units, yes? It went down 3. Now, when we talk about going down or decreasing, we're going to talk about it as a negative. The change in y was -3. It went down 3, yes? Now, how far did it go to the left and right? It went right 2. Well, right would be positive. Right and up are both going to be considered positive numbers. Left and down are both negative. They're going to be negative numbers. Questions on this here? Any questions? We good with this here so far? Can I reduce -3 over 2? No. So that's it. That's actually the slope. It's -3/2. Any questions on any of this here so far? So let's look at this next one here. So looking at this here, so first we want to describe the slope and then we want to find out what it is. So when I'm looking at this here, as the slope, as the line goes from left to right, how would we describe the slope? Is it going to be positive, negative, or sometimes we could have 0? It would be positive because the line is going up. So this would be the slope is positive. The slope is positive. The slope is positive. The slope is positive because it is going up as we go from left to right. It is increasing. Now we need to see what is the change in y over the change in x. How far is it going up and down? Over how far did it go left and right? So we're looking at over and up. So we can look at up and down. So how far did it go from here to here? Well, that'd be 1, 2, 3, 4, 5, 6. Let's see how far it went to the left and right. It went 1, 2, 3. The change in x would be 3. The change in y is 6. Would y'all agree with this here? Well, 6 divided by 3 would be what? 2, wouldn't it? Yeah. 6 divided by 3 would be 2. It doesn't always have to be a fraction. It can be a fraction. We could technically have decimal slopes. It doesn't have to be always a whole number or a fraction. It can be positive, negative. We can have a fraction. We can have a decimal. We can have almost any number as a slope. It's just comparing the rise over the run. Now, we could use the equation y2 minus y1 over x2 minus x1 because they did give us 2 points, yes? Because one of the points they gave us was this here, and the other one they gave us was this here. Now, our two y values are 3 and negative 3, because those are in the y value for the point, because a point is always in x comma y. So our two y values are negative 3 and 3. So which one would we use first, or which one do y'all want to use first? It doesn't matter. We can use negative 3 minus. The other one is 3. Now, once I decide which y goes first into this equation, its x value has to go first as well. Since I chose negative 3 to go first, negative 2 has to go first on the bottom. Minus. The other one is 1. Now at this point here, we can calculate it. Negative 3 minus 3 would be negative 6. Negative 2 minus 1 would be negative 3. Well, here a negative and a negative make a positive, and 6 divided by 3 would be, again, 2. So it still works the same. This formula will work as long as we have 2 points and we can plug them in. And here we do, and we could use the graph to find it. Questions on this here? We're going to do one more like this at least, because I feel like most of y'all are getting this, yes? Or at least have seen this before. So looking at this here, how would we describe the slope? The slope would be what? What do we think the slope would be for this here? You know? It would be negative because it's going what? Down. The slope is negative. The slope would be negative. So again, when we look at the actual value of the slope, we're looking at the change in y over the change in x. Change in y over the change in x. Do we want to use the slope formula or kind of do rise over run? Look how it changes on the graph. Which one do we want to do? Rise over run. So the rise is how far it goes up or down. So how far are we going down to get to this point? We have to go down 2, so it'd be negative 2. And then how far do we need to go over? 2, 3, 4. So we're going down 2 and over 4. Well, it's still going to be negative because there's only one negative on top and bottom, yes? Will 2 over 4, will 2/4 simplify? It will simplify to what? 1/2. So the slope here would be negative 1/2. And that's it. That's all we have to do for this here. Questions on this here? We feel comfortable with this here? And so we feel comfortable with those there. I'm going to skip those next three that show up, and we're going to move on to the next thing. The points represented by each table lie on a line. How can you find the slope of each line from the table? And what is the slope? Well, the slope, again, is the change in y over the change in x. Yes? So since this here is a linear function, the change in x from here to here is always going to be the same. And the change in y is always going to be the same. So that slope, our value of m, will tell us what that value is. So we can use the slope formula. Now, to use this slope formula, we need to pick 2 points. I need to pick 2 points. So I need 2 y values, and I'm going to need their corresponding x values. Now, you're probably wondering, does it matter which 2 points I pick? Well, no, because the slope is always going to be the same. So what's one y value out of all of those listed that we want to use? Doesn't matter which, we just need to pick one. What do you think? So 13 would be our x. We want one of the y's. So we can use 2. So we can use that 13, 2 as a point. So 2 would be on top and 13 would be on bottom because we want y over x, so 2 over 13, we can use that point. Now we just need to pick another point that we want to choose or use. Doesn't matter which. So we can use 8 and 10. So 8 would be our y, 10 would be our x, and we plug it in. Any questions on how we got this here? Any questions on any of this here so far? And it really doesn't matter which points we use, as long as we pick corresponding x and y values and plug them in. So when we simplify, 2 minus 8 would be negative, what? 6. 13 minus 10 would be 3. And negative 6 over 3 would be negative 2. And we'd have this here. So the slope would be negative 2. Now, yes, you could plug this into the calculator. The yellow calculators will do it. You can do the fraction key, 2 minus 8 over 13 minus 10, and hit enter, and it will tell you what the correct answer is. It'll tell you that it is negative 2, and it gives us our slope. Questions on this here? We good with this here? And I mean, we could have tried this again, say with 20 and 4 minus 2 and 13. I could have chosen the top and bottom points. Well, 20 minus 2 would be 18. 4 minus 13 is negative 9. And 18 divided by negative 9 would give us negative 2. So with any of these sets of points, as long as we put the y values on top and their corresponding x values on bottom and match them up, it will give us the same slope through any of these points here. Questions on this here? We good with this here so far? Let's look at another one. So how can we find the slope? Well, we can find it by using the slope formula from this table. y2 minus y1 over x2 minus x1. 1, 2, 3, 4. I'm going to just label those 1, 2, 3, 4 so we can kind of see which points do we want to use. The first set of points, second set of points, the third set of points, or the fourth set of points. Doesn't matter which, we just got to pick 2. So we can do 2, 3. So we can take this one here. Then I'll just pick one. Let's do the top one. Well, the y value is 2 and the x value is -1. Well, what is 2 minus 2? 0. 2 minus 2 would be 0. And the denominator, negative and negative, would make a positive. What is 0 divided by 4? 0. Because whenever we have 0 in the numerator of a fraction, it will always be 0. Can I ever have 0 in the denominator of a fraction? No. We can never have 0 in the denominator of a fraction. We can have it in the numerator. We cannot have it in the denominator. It never works in the denominator. So any questions on this here? So how can we find the slope from each line in the table? Well, we can use the slope formula. y2 minus y1 over x2 minus x1, and then we plug in the x and y values. So which 2 points do we want to use? The fourth one. So the y value would be 9. The x value is -3. How do we use -3, 0? Well, the y value would be, and the x value would be -3. Well, 9 minus 0 is nice, isn't it? Because what is 9 minus 0? 9. It would be 9. Because we're not really taking anything away or adding it, so it's just 9. Well, a negative and negative would make a. So -3 plus 3 is, well, 9 over 0 simplify. Can I have 9 over 0? Now, I'm going to delve into this a little bit, because really what we're saying, because we're saying 9 over 0 equals something, because that's kind of what we're saying. What would it equal? Well, this would be the same as if, because again, I can rewrite this as 9 equals x times 0. What times 0 will give us 9? Because what? Anything times 0 is always what? 0, yes? So is there any way I can multiply a number by 0 and get 9? No. Another way to think about this, and kind of like the dividing by 0, is we're trying to say, if this here was a hole, and I had 9 gallons to fill, and I keep pouring in 0 gallons into it, how long will it take to fill it? Well, if I keep adding nothing to it, will it ever get filled? No. That's essentially what this is saying and what we're talking about here. That's why we can't divide by 0, because it just doesn't work. So what this slope here is called, it is undefined. Whenever we get 0 in the denominator, or the values of x are the same. Because when we look at all these values of x over here, they're all -3, yes? So the slope is undefined. Because really what we're looking at is an equation that is going straight up and down. This is our vertical line. A vertical line has an undefined slope because there's no change in x. Now, when we have a horizontal line, when there's no change in y, it's 0. It's 0. Any questions on this here? How do we feel about these here? Good? Do we need to see another example of finding slope from a table? Do we feel good with this here? Okay. So really what we ended up looking at today was positive slope is going to rise to the right, negative slope is going to fall to the right. Zero slope does not go up and down, it's our horizontal line. And a vertical line, as we saw in that last one, has an undefined slope. The change in x is 0.